Dear students, welcome to B.R. Ambedkar Open University classes on geography course. We are talking about today a part of geomorphology. I am going to discuss about earthquakes and volcanoes. So normally we see earthquakes, volcanoes, cyclones are some of the disasters that has a serious impact on the population as well as on the ecosystem. So now these earthquakes and volcanoes, what we are calling as a natural hazards, they are actually a kind of outcomes that are happening, or that is output of some of the phenomena that is happening within the earth crust. So in this class we focus on earthquakes and volcanoes. What is an earthquake? So already we know what is an earthquake. An earthquake is a kind of a disaster that suddenly happens, that actually shakes the surface of the earth and results in the serious damage to the property as well as to the population. So now why this earthquake happens? What are the reasons? So there are different reasons postulated to know why these earthquakes are happening. Sometimes earthquakes even also happens in the sea and we term it as a tsunamis. So earthquakes are the intense shaking of the surface of the earth, especially the earth's outermost layer. So in order to understand the phenomena of earthquake, we should know what are the different layers that are actually be found within the earth's surface. So typically there are three layers, what we call as the outer very hard structure, that is the crust, and there is a mantle below the crust, and below the mantle we have core region, which is again divided into two as outer core region and inner core region. Inner core region, it is a solidified structure, while the outer core is the molten stage or in the liquid stage. So now we have this mantle, what we see in red color, this mantle, and the upper part of the mantle along with the crust. So normally earth crust appears very hard, but below the crust we see this gentle mantle. The upper portion of the mantle along with the crust together forms the lithosphere. So this lithosphere, actually it is one that encircles the earth, but actually it is not a continuous surface. It is actually something like what we see a jigsaw puzzle, which is a discontinuous layer. Now these lithosphere, actually they are divided into, it is divided into plates, and these plates we call them as a tectonic plates. These tectonic plates, they move on this mantle, which is a viscous substance. So the movement of these plates usually results in some kind of friction, and this friction creates some kind of stress that actually may lead to some kind of these disasters. So if you see the lithosphere, we see entire globe having different plates, and these plates are the tectonic plates. The edges of the tectonic plates are called boundaries. Now whatever the serious earthquakes which are happened overall, so this is a figure showing from 1900 to 2017. We can see a series of earthquakes that happened globally, and each color represents the magnitude of the earthquake intensity. So what is the strength at which this earthquake happened, and what is the peak ground acceleration that actually resulted in this kind of earthquakes. So we can see the black one, which are actually the mega or the major earthquake sites. Then we have these different color, the red colors forming the other categories. So we have these different types of earthquakes, and if you observe these earthquakes, they almost happen along the tectonic boundaries. So most of these either earthquakes or the volcanoes, they are reported to happen along these tectonic plates, because these tectonic plates, they are always in a state of motion. They collide with each other or they brush past each other, and that actually create this kind of either earthquakes or the volcanoes, and these are the serious disasters. So if you see a picture here, now we have these plates. So plates are moving each on either side, so something they may collide or they may just pass over it, and this actually creates the friction. So now this, there will be always a non-continuous movement of these plates, and these plates actually over time actually create some kind of this friction, which is actually we can see on the surface of the earth as a fault layers. So usually when there is a kind of stress happens on the within these plates, we can see them as a cracks on the surface of the earth as a faults. So most of these earthquakes what we see, they usually happen along these faults. So this is an example of California, where we can see a fault line that is actually an outcome of the collision between the plates, tectonic plates. So now when these plates they rupture, so slowly they brush past each other, this slight colloidal movement. But sometimes this kind of movement results in a huge stress, and this stress actually finally results in the form of a seismic waves. So mostly sometimes when there is a collision, when they brush past each other, there may be some kind of friction, but sometimes there may be locking, and this locking between the two plates results in some kind of a stress, and the energy, that energy is released in the form of waves, and that waves actually what we call as a seismic waves. That is the result of the earthquakes. So primarily these tectonic plates are the collision or the movement of these plates in a stress condition are the results of the earthquakes. So now we have the two terminology here. One is the hypocenter and another is the epicenter. Hypocenter is the location within the surface of the earth where actually this kind of triggering of the earthquake or the seismic waves happen. And the point exactly above this on the surface of the earth where we can see that kind of output of the earthquakes, we call it as a epicenter. So we have this hypocenter. It is also sometimes referred as the focus point of the earthquake. And on the top of the surface we can see this epicenter location where actually we can see these waves, they pass over and finally they cause the disaster. So now whatever the energy that is actually coming out of the rupturing of these tectonic plates, that results in the formation of seismic waves. So energy in the form of waves. Now these vibrations or the waves, they pass and finally they create the disaster. So mostly the seismic waves or the earthquake triggered waves, there are three types. One is the surface waves. So these surface waves, they move all over the surface of the earth. They up and down as well as the to and fro, they move on all the sides of the earth, and wherever they actually pass, they create the damage. So totally they bring such kind of disaster in the path of movement of these surface waves. While we have one more kind of waves, that is the P waves. P waves also move in the side to side of the crust along the entire internal surface, and these P waves, they pull as well as the push the rock material that is coming on their path. And third category we have S waves. S waves, they move only side to side and they actually cannot pass through the liquid medium, so they don't pass into this outer core region, while they are restricted only to the upper surface. So whatever the result of these earthquakes, it is typically happening because of the intensity, the magnitude with which these vibrations of these waves are moving and finally causing the disaster. Usually there is a old-fashioned seismograph, how to measure what is the magnitude of the earthquakes. So in the previous slides I shown the different colors indicating different magnitude of the earth crust, earthquakes. So how actually we represent such kind of magnitude? So typically we talk about the magnitude, that is what is the strength of the earthquakes, and we also talk about the intensity. So we use two words, magnitude and intensity. Magnitude talks about the strength of the earthquake, while intensity talks about the what is the amount of the shaking. So typically based upon this magnitude and intensity, we classify earthquakes into different categories, either as a mega earthquakes or the major earthquakes or the mini earthquakes. So how to calculate such kind of magnitude or the intensity? So we have seismographs. So this seismograph, it is actually equipment which is having a pen that is attached to a weight, and there is a rotating drum. So whenever there is a earthquake, we can see shaking of this drum. The movement of this drum, the rotating drum, actually when there is a shaking of the earth, so whatever the intensity that is happening within that particular location, that is actually drawn by this pen, and this actually lines indicate the intensity of earthquakes. So currently we have a different modern seismograph, which is actually, instead of having this suspended weight with the pen and the rotating drum, we have a electromagnet. This electromagnet typically identifies the vibrations of these earthquakes, and actually it converts those vibrations or the waves into voltage, and this voltage is actually recorded within the system. So that actually gives what is the magnitude and the intensity of the earthquakes. So now we know what is the magnitude of the earthquake, but how to know that where it is actually located, and how far, what is the probability that it can expand to the nearby regions. So now to identify, so to know the magnitude, we use a seismograph to know what is the variation in the intensity of the earthquake. So to know where actually it is locating, typically we will consider these P waves and the S waves. S waves travel slower compared to that of the P waves. So now the distance between the P and the S waves will give me what is the chances that it may spread to the nearby areas. So based upon this time interval between the P and the S waves, we can locate actually what is the nearest region that these earthquake can occur. So we have this kind of classifications based upon the magnitude. As a magnitude greater than 8, we are calling them as a great earthquakes. So we have globally a number of great earthquakes that happened with a serious damage. So we have magnitude greater than 8, then we have magnitude less than 1 as the ultra and micro earthquakes. So normally these plates, they keep on moving on this viscous substance. So there are minor movements which are actually not traceable. Whenever there is a collision that actually results in the high vibration stress or the friction, that actually results in the surface waves or the P waves with the maximum magnitude, with the energy, that actually results in the earthquake. So we often feel such kind of, have this kind of micro earthquakes which are not detectable or the traceable. So till to 5 to 7 we have these moderate earthquakes, but maybe 3 to 5 maybe small earthquakes. We often hear within the part of the country or globally occurrence of this kind of small earthquake. They say that there is a tremor in the location, but on the Richter scale it was recorded as something magnitude of 3 or 5 or 4 like that. So usually these are pretty small kind of intensity of the earthquakes that may not create any damage, just they bring such kind of a shaking of the buildings or the location areas, but it does not cause any casualties. But these something more than 7 are really something is creating this kind of hazards, causing damage to population as well as the property. Similarly, based upon the intensity of the spread, to what extent these earthquakes are spreading. Suppose now we have this epicenter and we have the hypocenter. So from the epicenter, how far these waves are traveling and which parts are actually damaged by this earthquake. Based upon such kind of distance measurements, we have these teleseismic earthquakes. So they are propagating greater than 1000 kilometers, and we have regional earthquakes greater than 500 kilometers and local earthquakes less than 500 kilometers. So it depends upon what is the magnitude and what is the intensity with which these waves are propagating that actually trigger such kind of earthquakes in the smaller areas or to the larger areas. So if you classify based upon origin, how these earthquakes are actually forming. So one is the tectonic. So just now we have discussed about the tectonic. The movement of the tectonic plates results in the earthquake. Sometimes earthquakes also happen because of the volcanic eruptions. Volcanoes are also formed because of these tectonic plate movements, and volcanoes are also responsible for some kinds of earthquakes. So the magma beneath the crust may also trigger some kind of earthquakes, but these are something very rare, and the casualties are not that much high compared to that of the earthquakes that are typically caused by the tectonic plates. Then sometimes earthquakes may also happen because of the collapse. So collapsing of the huge building, or earthquakes resulting in the collapse of the building, that can also result in the triggering of the earthquakes. But these are something very rare phenomena. And similarly we have the explosion. Any explosion that also results in the earthquakes. So collapse earthquakes and explosion are something very rare, but we see most of these earthquakes are happening because of the tectonic plates collisions. So we can see a list of earthquakes which are actually occurred globally. So we can see in the Chile, it is around 1960, its magnitude is around 9.5. So it is a one of the largest or the mega earthquakes that happened in the history. So we have this kind of list of earthquakes, and if you locate based upon the latitude and the longitude, if you observe these earthquakes, they happen mostly along the boundaries of the tectonic plates, because these tectonic plates are the primary sources that are responsible for this kind of earthquakes. So the intensity depends upon what is the energy that is released by the collision or the rupture of these tectonic plates in that particular region. So now within the country we can see different seismic zones. So country is divided into, as per this map, Bureau of Indian Standards, they divided entire country into 4 different zones. So zone 2, zone 3, zone 4 and zone 5. So initially there are 5 zones. So around 1962 they defined 6 zones for India. In 1966 again it reduced to 6 zones. In 1974 and 1984 again they changed it to 5, but currently we have only 4 these seismic zones. So they combined 1 and 2 into second group. So now this 5 and 6 talks about what is the intensity. So if the intensity is between 5 to 6, they are calling it as a low seismic zone. So mostly we can see that is represented by this kind of zone 2 is the blue one, which is you can see. So we have zone 3, zone 4 and zone 5. So this is typically based upon the intensity. As I mentioned, what is intensity? It is the amount of the shaking of the ground. So usually the units for this intensity is modified meterically. You can see it as a mm. So based upon this intensity, entire country is divided into 4 seismic zones. The high what we see mostly in this northeast zone, which is having very high seismic zone. So that finishes the part of earthquake. Now coming to what is a volcano. Volcanoes are also one of the hazards. You can also call them as a natural hazards that are also typically happening because of the tectonic plate movements, or these are the results of the magma that is actually formed within the earth crust. So if you see a volcano, it has a vent. Vent is the opening through which actually we can see the lava. So this vent is connected to the bottom with a magma chamber. Magma is a molten rock material. So the high temperatures within the earth crust actually melts the rock, and that actually forms as a molten magma, molten liquid as a rock as a magma. So this magma, when it comes out of the vent, then we calling it as a lava. Vent is connected with the magma chamber through a pipe called conduit. So when the lava overflows, actually it spreads within the surrounding areas of the vent region. Here actually this is consists of maybe the ash or the some kind of pyroclastic materials. So depending upon the type of the volcanoes or type of the material that is present within the earth molten magma, we can see different kinds of chemicals that are actually coming out of the magma as a lava, and finally they are deposited within the surroundings of the region. So this actually forms a kind of a cone like structure. So it can be a cone like structure, or it can be something like a dome like structure, which is actually mostly the depositions of this kind of lava that is actually erupted from the earth's surface. So how volcanoes are formed? Volcanoes actually, we can see the structure of the earth, as I mentioned, the crust, mantle, outer core as well as the inner core. So deep in the earth actually it is hot, and this is actually results in the melting of the rock forming the magma. This magma actually it comes out through the weak structures on the surface of the earth, which are actually kind of a fissures that makes this magma to come out of the burst out as a lava. So we can see the lavas mainly because of this kind of eruption process. So over the time, the magma which is actually coming out of the lava, it is deposited on the surfaces, and that is finally forming a cone like structure. It can be a cone or a dome like structure. So over time the depositions actually makes the volcano looks much bigger compared to the initial starting conditions. So now where are these volcanoes are located? As I talked about earthquakes, earthquakes are located mostly along the boundaries of the tectonic plates. Similarly, if you see these volcanoes, they are actually concentrated around this region what we call as a ring of fire. So this entire region starting from tip of the South America to the coast of the North America, finally crossing with the Japan, and finally with the ending with the New Zealand. So this entire belt actually it is a zone where actually we can find these frequent volcanoes. So this actually called as a ring of fire, which is in the Pacific Ocean region. It is like a shape of a horseshoe, and it is actually home for 90% of the world's earthquakes. So not only the volcanoes, we can also see earthquakes. So a combination, these rings of fire has both the hazards, earthquakes as well as the volcanoes. So 90% of the volcanoes and 75% of the earthquakes are actually focused in this ring of fire. So as I mentioned, it starts from it's a string. So along this ring of fire, there are around 452 volcanoes, which are actually starting from the tip of the South America and finally ending with the tip of the New Zealand. So why do volcanoes erupt? Over time, when this magma is built within the molten layer in the region, in the mantle region, some kind of a pressure is created, the pressure or the friction. This friction typically causes the volcano, the magma to come out of the vent and finally form as a lava. So how this volcano erupts? It is also, as I mentioned, because of the tectonic plates. So as per the plate tectonic theory, the friction between the tectonic plates along the edges actually that are primarily responsible for this kind of volcanic eruptions. So normally, as I mentioned, where there is something a weak land, weak portion of the surface, that is the main point for the eruption of the volcano. So mostly in the tectonic plates, the mainly results for this kind of volcanic actions. So there are different types of volcanoes we can see based on the frequency. So we call them as active volcanoes, which are actually currently also they are showing their kind of volcanic activities, which are recent one, which are very active, and the eruption started long back, but again there is a possibility that they may still erupt. Then we have the dormant. They erupted for some short time, but again they remain silent. So they may erupt in future. Those are the dormant. We can also call them as a semi-dormant volcanoes. And finally, we have something called extinct. So these volcanoes, they actually were active in the long past million years ago, and the chances of again eruption is totally a question. So we can classify them as active, dormant, and extinct volcanoes. So based upon the types of eruptions, some volcanoes happen very quietly. They release the lava, magma in the form of the lava, which actually on its path damages all the property as well as the structures, vegetation, everything. While there are some eruptions which are very explosive, that actually releases large of this lava in the form of pyroclastic flows, which actually we call them as ash or the rock segments. So depending upon the type of the shape of the cones, we have, based upon the eruptions, we have cinder cones. So this is a cinder cone example. Okay, so this is found in example is we can find this in the Mexico. This is a real picture. Then composite volcanoes, which are actually have multiple vents. Example is Mount Fuji in Japan. Then we have the shield volcano. It forms something like a shield-like structure. So continuous eruption of the lava that actually overflows and finally forms a shield-like structure. So what we found in the Hawaii island, so the Mauna Loa is one of the greatest, largest volcano in the world as well as in the island of the Hawaii. Then we have lava domes. It is typically very viscous lava that does not flow much distance. As a result, they are deposited within nearby areas. So this actually we can see in parts of Alaska. This is a real picture of the lava domes. So these are the different types of volcanoes what we can see. So Barren Island and Narcondam. So within the country we have, these are the islands. Barren Island, which is a very active volcano, and Narcondam, it is dormant, and Baratang Islands is a mud island which is also active, and rest are actually unknown and some are extinct. So within the country we found these volcanoes within the Andaman Islands. So this is in the Barren Island and this is in the Narcondam Island, which is a dormant, may not erupt in future, but this is actively erupting. And this is the Baratang Island, which is a mud volcano, which is a very active. So sometimes, as I mentioned, earthquakes also happen within the oceans. So this is what we call them as a tsunami waves. So now these waves, as I mentioned, when they are within the ocean, they does not actually have very good height, but once they reach very near to the coast, near to the surface of the coast, we can see there is a increase in the height of these waves, and these tsunami waves actually typically causes very huge damage.